So, what are motor drives, their importance and types of motors? So as we have learned earlier, motor drives are systems which consist of motors to accomplish certain tasks. For example, when we utilize motors in our car systems for mobility, what do we do? If it's a car, just turn the motor and the wheels will take you wherever you want to go, right? Just simple. For escalators or tanks or lifts, they also follow the similar kind of mechanism. You just you turn the motors on to move the wheels, and when the wheels start to revolve, what happens is they tend to take some payload and they tend to move everything around. Okay, so there are examples. You could say that their usage are in different areas, like in malls, supermarkets, and various kinds of robotic systems. Okay, now let's learn about types of motors. Okay, so there are commonly 4 types of motors present and used in the world for robotic systems are DC motors, that is direct current motors, which uses direct currents. We're going to learn more about it in detail in a bit. Then we have AC motors, that's alternating current motors. Then we have stepper motors. Then we have servo motors. Okay, and there are also variation and mix in each of them for optimum output. Okay, sometimes they would mix and match, okay, just to have a better output of the motors. Okay, so let's learn from these motors now a little bit more about these systems. Okay, so DC motors usually run on DC currents. DC currents are the ones we get from batteries or cells. Okay, they're direct, they do not change directions. If you would like to learn more, we're going to make a course on electronics and electricity. Okay, so stay tuned for that. Now if you pass the current in the other direction, it will rotate in the opposite way, since it's a DC motor, so they'll just change the direction of the rotation, okay, due to the magnetic field that is created due to the current. Okay, now let's learn about AC motors. So AC motors are the ones that are alternating current motors. So here what happens is the current changes direction every second. Okay, so it alternates up and down. Okay, and when it happens, what happens is your motors they AC motors, basically they used a different kinds of stator and rotor. Okay, so now let's learn about what's a rotor and stator in a motor. Okay, so a stator is basically a static substance in a motor. That means a magnet or something that is generating the magnetic field, and rotor is the component that rotates. Okay, now for the AC motor, what happens is the stator is the things that are static is basically wires, which creates a flux by the AC change or alternating current change, and the rotor is the thing that rotates same as before. Okay, so now that's the difference between DC motors and the AC motors. Okay, so DC motors need their permanent magnets, but AC motors do not. Okay, so you just need a bit of wire to create the AC motor, and AC motors are quite powerful and they're used all over the world. Okay, because DC motors require a lot of power, and you would need a lot of battery for the bigger ones, so which is not sustainable. Okay, and now let's learn about servo motors. The servo motors, any motor with a feedback system which can be operated at a desired value of rotation. Okay, so that's why they're known as servo motors. Okay, so you can rotate them with desired value of rotation, like you can make them move of a particular angle, maybe 90 degree, 30 degree, 40 degree, whatever you want. Okay, it should be calculated on your microcontroller, and pulses would be sent to your motors using pulse width modulation. Now let's learn about stepper motors. Okay, so stepper motors usually steps of a known angle each time it is moved. Okay, so you always know the steps, basically, so that you have like a particular set of rotation around. So you have teeth, you have calculated it beforehand. It looks like a gear, and so their driver, it's basically the rotating magnetic fields in its windings drives the stepper motor. Okay, so it's usually used for non-industrial use in probably tooling machines in the control areas, and they're mostly for automatic manufacturing. Okay, so we're going to learn more in depth about these motor systems in our course 2. Okay, and thank you for listening.